Welcome to HFCL Time Machine. Past, present, future, all connected.
Let's step into today's chapter where we explore Wi-Fi 8 and what it means for the future of ultra-reliable wireless connectivity, immersive digital experiences, and always-on intelligent networks.
Absolutely.
Before we really get into the mechanics of this, I want you to imagine something. Picture a sprawling, modern manufacturing plant.
Right.
You have these massive autonomous robots, right? Moving materials across the floor at, say, 30 miles an hour, working right side by side with human engineers.
Right. A very high-stakes environment.
Exactly. Now imagine if the localized wireless connection that is guiding those multi-ton machines drops or, just lags for half a second.
Yeah, the results would be catastrophic.
Right. So today we are doing a deep dive into the technology designed to make sure that specific scenario, and honestly a million smaller daily frustrations, never, ever happen.
It is a phenomenal engineering challenge to solve, honestly, because, see, for the better part of 2 decades, wireless innovation has essentially been caught in this relentless speed race.
Yeah, totally.
It was always about chasing higher peak speeds, larger bandwidth, faster downloads. And to be fair, the industry achieved remarkable things on that front.
Oh, absolutely.
I mean, if we look at the baseline established by the Wi-Fi 7 standard, we are already looking at multi-gigabit throughput.
Right, the speeds are incredible.
Exactly. We see sub-10 millisecond latency in controlled settings and packet loss rates sitting comfortably below 0.1%. So by all traditional laboratory metrics, the basic problem of speed has been thoroughly solved.
Which makes today's deep dive so compelling, I think, because the source document we are unpacking today, which details the upcoming IEEE 802.11bn standard.
Basically what we will all soon know as Wi-Fi 8.
Yes, Wi-Fi 8. It reveals this fundamental pivot. The technologists and the engineers aiming to finalize this standard by 2028 they are officially stepping off the speed treadmill.
They are.
Instead, they are turning their full attention toward achieving what they call wired-grade reliability.
Yeah, and that phrase, wired grade, is really the entire philosophy here. The engineering community is moving away from asking, how fast can this network perform in a straight line on a test bench?
Right.
And they are now asking, how perfectly can it perform when real-world conditions are absolutely terrible?
I think we can all relate to that need on a personal level, right? You know that familiar frustration when your video call abruptly drops just because you walked from your living room into the kitchen?
Oh, happens all the time.
Or perhaps you are sitting in a crowded stadium and your phone screen proudly displays a full Wi-Fi signal, but your actual data connection completely crawls to a halt.
Right, the classic fake full bars.
Yes. So we are diving into the mechanics of why the industry is fundamentally redesigning the network to make those dead zones a thing of the past.
Understanding the framework behind this shift is crucial. And this brings us to the core of the 802.11bn mandate, which is the UHR initiative.
UHR stands for Ultra High Reliability, correct?
Correct. The IE scope document does not just offer, vague promises about better connections. It outlines a very clear, measurable vision to elevate performance.
Okay.
And it does this by drastically improving the absolute worst-case scenarios a device might face.
Right, and the document mentions the working group establishing what they call the 25% rule to measure this leap over Wi-Fi 7.
Yes, the 25% rule.
Okay, let's unpack this because it seems to be the North Star for the whole project. The first metric is targeting at least 25% higher throughput, but specifically in challenging signal conditions.
That's right. They are not interested in the clean lab environment anymore. They are measuring success in the noisy, interference-heavy environments we actually inhabit every day.
Makes sense.
But the second metric is where their methodology becomes truly revealing. They are aiming for 25% lower latency, but specifically measured at the 95th percentile of the latency distribution.
Oh, wait, let me pause you right there because 95th percentile of latency distribution sounds like something that requires a whiteboard to explain.
It does sound a bit academic, yeah.
So if I am reading this right, it means they aren't just looking to improve the average lag. They are actively hunting down those rare, severe lag spikes, like the worst 5% of moments where the network stutters or freezes.
Exactly.
And they are focused entirely on smoothing those out.
That is a perfect translation, actually. See,
Okay.
the average latency on Wi-Fi 7 is already excellent, but averages hide anomalies.
Oh, that's true.
If your connection is lightning fast for 59 seconds, but freezes completely for 1 second, your augmented reality headset will literally make you nauseous.
Oh, wow. Yeah.
Or your automated factory robot will trigger an emergency stop. So by targeting the 95th percentile, the engineers are attacking the anomalies directly.
I see. And the third metric of this rule ties directly into that, right? Achieving 25% fewer dropped packets, particularly when a device is actively roaming between different access points. So if I am understanding the overarching philosophy here, it sounds like we are shifting focus from building a flashy sports car that can hit 200 miles per hour on a perfectly flat, empty test track,
Right.
to building an absolute beast of an off-road vehicle, one that guarantees it will maintain exactly 60 miles per hour without fail, even while driving through a congested, muddy jungle.
I love that analogy.
It might not boast a higher top speed on the brochure, but it never, ever gets stuck.
The engineering reality maps onto that analogy beautifully. But to understand the how, we have to look at the physics for a second.
Okay, let's do it.
In wireless network, when a signal encounters a muddy jungle, say thick concrete walls or a barrage of competing signals, the signal-to-noise ratio, or SNR, degrades rapidly.
Right, the noise takes over.
Exactly. What's fascinating here is that Wi-Fi 8 is implementing advanced modulation schemes and error correction protocols specifically designed to decipher data when the noise is almost louder than the signal.
That is incredible.
The goal of the UHR initiative is basically to replicate the invisible, unbreakable tether of a physical Ethernet cable straight through the air.
That is an incredible ambition. But pushing on that off-road vehicle analogy for a moment, why is the jungle of our digital environment suddenly becoming so dense that we require this massive architectural pivot?
That is the big question.
Like, what are the transformative trends forcing this evolution right now?
So there are two major catalysts that are dramatically increasing both the density and the dynamism of our local networks.
Okay.
The first is the sheer rise of AI-driven systems. We're talking about intelligent systems embedded into our environments, wearable devices, and completely autonomous machines.
Right.
These systems do not just need a connection to download a static file. They demand continuous, highly reliable, ultra-low latency connectivity to access edge servers or cloud-based AI for real-time inference.
Because they are making split-second decisions about the physical world around them.
Exactly.
And real-time inference implies a constant conversation. If the network drops for even a fraction of a second, the AI basically loses its context of the environment, and the inference fails.
Precisely. The system essentially goes blind.
Wow. Okay, and what is the second catalyst?
The second catalyst driving this is the incredible proliferation of personal device ecosystems.
Like smartwatches and things.
Yes. Think about next-generation augmented reality glasses, real-time health monitors, spatial computing headsets. These are no longer independent devices. They are constantly talking to each other.
Ah.
Your AR glasses, for example, are likely offloading incredibly compute-intensive rendering tasks to a companion device, like the smartphone in your pocket.
Just to save weight and battery on your face, I assume?
Exactly. And that requires incredibly high throughput, remarkably low latency peer-to-peer links.
Okay, wait. I have to challenge this premise for a second.
Sure.
We have 5G networks blanketing our cities right now, and we just established that Wi-Fi 7 is pushing multi-gigabit speeds. Why is the localized short-range Wi-Fi connection suddenly the critical bottleneck? Like, why can't these AR glasses and autonomous systems just rely on the incredibly robust macro networks we just spent billions of dollars building over the last decade?
That is actually a very crucial distinction to make. Wide area networks like 5G are brilliant for connecting your device to the broader internet.
Right.
But Wi-Fi 8 is being defined as the foundational connectivity fabric for local, immediate ecosystems.
Meaning the devices right next to each other.
Exactly. When your AR glasses need to render a complex 3D object based on processing done by the phone sitting just 2 feet away in your pocket, sending that data out to a 5G cell tower a mile down the road, processing it, and bouncing it back introduces an unacceptable level of latency.
The round trip takes too long.
It physically breaks the laws of physics required for real-time spatial computing.
Oh, I see. So it is the internal conversation between the devices in your immediate physical vicinity that needs to be bulletproof. It isn't just about reaching the cloud. It is about reaching the device right next to you.
It is entirely about localized peer-to-peer communication. The local network needs to support these massive data flows just as robustly as it supports a traditional internet connection.
Okay, so now that we understand the urgency and the why behind this necessary reliability, let's look under the hood.
Let's do it.
How does the 802.01bn standard actually achieve this in the real world?
Yeah.
The source document outlines 5 critical pillars.
Yes, 5 pillars.
The first one addresses something that has been a personal pet peeve of mine for years, which is seamless roaming.
Oh, yes. And the mechanism they're using here is a truly transformative approach to mobility.
How so?
Well, Wi-Fi 8 introduces the concept of single mobility domains. To understand why this is revolutionary, consider how your device operates right now.
Okay.
When you walk through a large office building, your phone is constantly evaluating the signal strength of the router it is currently connected to.
Right, it's always scanning.
Yes. And when that signal gets weak, your phone has to abruptly sever the connection, hunt for a new access point, negotiate a fresh handshake, authenticate your security credentials, and finally reconnect.
And during that entire negotiation process, the data completely stops flowing. That is exactly why the video call freezes when I walk down the hall.
Exactly. The device itself is acting as the decider, and it is a very clumsy process.
So how does Wi-Fi 8 fix it?
Single mobility domain flipped this architecture entirely. The access points themselves coordinate on the back-end network infrastructure.
Oh, the routers talk to each other.
Yes. They share your device's connection state and security credentials in real time. So as you walk down the hallway, the network infrastructure seamlessly hands your connection from one antenna to the next.
Wow.
Your phone never even realizes it switched routers. It literally believes it is connected to one giant unified access point.
That is brilliant. The result is a once connected, always connected experience without a single dropped packet.
Precisely. The network takes the burden of decision-making away from the device.
Now, if we follow the logic of mobility, that flows directly into the second pillar, which is reliable edge coverage.
Yes.
Because if you are moving around, eventually you reach the physical limit of the network, right? How does Wi-Fi 8 stop the connection from just falling off a cliff?
This ties back to the 25% rule we discussed earlier, basically strengthening the weakest links.
Right.
When a device operates the very outer boundaries of an access point's coverage area, the signal becomes incredibly fragile. Wi-Fi 8 includes physical layer enhancements that change how data is packaged and transmitted in these low-signal states.
So it adapts on the fly.
Exactly.
Yeah.
It dynamically shifts to highly resilient modulation schemes. You might not get maximum throughput out there at the edge, but the standard guarantees the connection remains stable and usable.
Rather than simply dropping the connection when conditions get tough.
Right. It prioritizes stability over absolute speed at the edge.
Okay, so we have solved how a device moves seamlessly and how it survives at the edges. But what happens when you have the exact opposite problem?
Like too much density.
Yeah. Too many access points in the zona. This brings us to the third pillar, and here's where it gets really interesting. Smarter coordination for dense deployments, or what the document calls multi-AP coordination.
This is a huge one. High density is perhaps the most complex environment for wireless networking. Think of massive enterprise campuses or crowded event spaces.
Right, tons of routers everywhere.
Exactly. Historically, overlapping signals and airtime contention are massive problems. The routers are literally fighting each other for the same radio spectrum, shouting over one another.
Which causes massive latency spikes and degraded throughput for everyone.
Correct.
If I can visualize this, instead of 2 independent access points acting like people shouting over each other in a crowded room, Wi-Fi 8 turns them into synchronized dancers.
I like that.
They share the physical space perfectly, so the listener doesn't experience any interruption. But how do they actually choreograph that dance mechanically?
See, the choreography is dictated by a unified internal clock. Through multi-AP coordination, the access points literally share scheduling data over a back-end fiber connection.
Oh, wow.
They communicate their transmission intentions and slice up the available radio spectrum in milliseconds. Instead of colliding, their signals interlock.
So they coordinate before they broadcast?
Yes. If one router needs to transmit a massive burst of data, the neighboring router will mathematically calculate the exact microsecond to pause its own transmission.
That is insane.
Or it will dynamically shift to a different spatial stream just to avoid interference. They act collaboratively as a single intelligent entity.
That collaboration sounds essential for a busy office, but what happens when the interference isn't coming from across the room, but from inside the very phone in your hand?
The internal interference.
Yeah, because modern devices have Wi-Fi, Bluetooth, and cellular radios stacked millimeters apart. That leads us to the fourth pillar, improved in-device coexistence.
This is where the engineering becomes almost microscopic. The physical proximity of these antennas within a smartphone or a smartwatch creates serious physical challenges.
I can imagine.
When your Bluetooth radio transmits, it can literally deafen the Wi-Fi receiver sitting 3 millimeters away from it on the circuit board.
Wow. And previously, this just resulted in unexplained data loss.
Exactly. You just get a glitch. But Wi-Fi 8 introduces sophisticated mechanisms to gracefully handle this.
It essentially functions like an incredibly efficient air traffic controller living right inside your phone's processor.
That is the perfect way to look at it. The standard uses microscopic time division multiplexing.
Okay, what does that mean?
Basically, the Wi-Fi controller and the Bluetooth controller negotiate blanking intervals at the microsecond level. The Wi-Fi radio knows exactly when the Bluetooth radio is going to pulse.
Oh, so it anticipates it.
Yes, and it schedules its data packets perfectly around those micro-interruptions. It ensures smooth operation without temporary outages, even when multiple radios are forced to share the exact same physical antenna.
And performing those microsecond gymnastics constantly must take a toll on battery life. Which brings us to the fifth and final pillar. Smarter energy use.
Very true.
Because with all this constant connection, peer-to-peer networking, and microscheduling, power efficiency is clearly a massive concern.
It is absolutely paramount. As Wi-Fi becomes the central nervous system for everything we do, power efficiency isn't a luxury anymore. It is a fundamental requirement.
Right.
Wi-Fi 8 introduces deeply energy-aware features, specifically enhancements to a protocol called target wake time.
Target wake time. How does that work?
The network controller can negotiate with a client device to essentially put its Wi-Fi radio to sleep for calculated microintervals when data isn't actively flowing.
Oh, so it sleeps for like fractions of a second.
Exactly. And over time, this dramatically extends the battery life of client devices like AR glasses or IoT sensors.
And it also reduces the power draw on the infrastructure side, right? Because sustainability has to be factored into running millions of access points globally.
Absolutely. The standard allows fixed access points and residential gateways to power down specific spatial streams or antennas during periods of low demand.
That makes total sense.
It massively reduces the constant energy consumption of the network, all while maintaining the capacity to wake up instantly when that real-time responsiveness is demanded.
So when we put all of this together, we have this beautifully orchestrated system, single mobility domains, edge performance, synchronized multi-AP coordination, microscopic in-device coexistence, and intelligent energy management.
Quite the list.
It is. We have covered the highly technical how. Let's transition to the practical where.
Right.
How will this off-road vehicle of a network actually change the physical spaces that you and I live and work in?
The impact will be profound, actually, and the source material highlights 3 primary environments where this transformation will be most visible.
Let's start with enterprise environments. We are looking at a fundamentally new era of mobility and automation in smart factories, massive logistics hubs, and modern hospitals, right?
Yes. The source specifically mentions mission-critical use cases like autonomous guided vehicles, or AGVs, and collaborative robots.
Okay, yeah. To go back to your scenario at the beginning of our discussion, on a smart factory floor, you have dozens of autonomous robots moving heavy materials.
Right. And these machines cannot afford a 500 millisecond latency spike.
Because a half-second delay in receiving a braking command is a massive safety hazard.
Precisely. But because Wi-Fi 8 delivers that wired-grade reliability, these mission-critical workflows can operate safely while in constant motion.
So the network ceases to be just a convenience layer for employees checking emails.
Yes, it becomes the literal core infrastructure enabling heavy automation at scale.
That is a massive paradigm shift for industrial operations. But what about closer to home? The second environment the document highlights is home connectivity, and they focus heavily on multi-dwelling units, or MDUs.
Yes, MDUs. Think of large apartment buildings. They present one of the most hostile RF environments on the planet.
Oh, I can imagine. Everyone has their own router.
Exactly. If you live in a large apartment complex, you are essentially swimming in a sea of interference. You might have 50 different routers broadcasting at maximum power within a 100-foot radius.
Right.
But the connected home is evolving far beyond just streaming movies on the couch. We are increasingly relying on predictive automation, persistent real-time health monitoring systems, and immersive spatial computing.
And you definitely don't want your real-time heart rate monitor to drop its connection just because the family in the apartment next door decided to download a massive 100-gigabyte video game update simultaneously.
Exactly. Wi-Fi 8's multi-AP coordination and advanced modulation techniques make it possible to deliver these high-demand, high-reliability services consistently.
It cuts through the noise.
Right? It cuts through the noise of those 50 competing networks to ensure both the critical health monitor and the massive game download operate flawlessly.
Which brings us to the third environment, public spaces. Think of sprawling international airports, massive sports stadiums, transit hubs.
The toughest environments of all.
Truly, these are traditionally the places where we all instinctively expect to have zero signal the moment the crowd gets too thick.
Yeah, the ambition for these venues is staggering.
Yeah.
They are evolving from mere physical transit points into hyper-connected digital experiences.
Because the sheer density of devices in an airport terminal is a nightmare for legacy Wi-Fi.
It really is.
So what does this all mean for you, the listener, the next time you travel? For you, this means walking from the airport check-in counter, navigating through the densely packed crowds at security, and making the long trek all the way to your departure gate.
Right.
And while you do this, you are looking through augmented reality navigation on your smart glasses. Perhaps you have an earpiece providing a real-time AI translation of a gate announcement while simultaneously streaming a 4K video to your tablet.
That is a lot of data.
It is. And through all of that movement, your connection never blinks. No buffering, no dropped packets, no manually toggling your Wi-Fi on and off just to get a signal. Just an invisible, perfect stream of data.
And the truly remarkable part is what is actually happening behind the scenes while you do that.
What do you mean?
Well, the airport authority is using that exact same wireless infrastructure to run their critical security systems.
Oh, of course.
They are managing high-definition, low-latency video surveillance, coordinating massive arrays of environmental sensors, and tracking the real-time movement of staff and assets across 1 million square feet of space.
All on the same network.
All on the same network. Wi-Fi 8 ensures that all of these streams, your high bandwidth, personal entertainment, and the facility's mission-critical operations, run simultaneously without stepping on each other, even during peak holiday travel times.
Wow. It is genuinely difficult to wrap your head around just how much complex data will be flowing through the air, perfectly synchronized.
It really is mind-boggling.
And as we zoom out on all of this, working groups and technologists right now, from major silicon companies like Qualcomm and across the various IE committees, they are actively collaborating to finalize the 802.11bn standard.
Yes, the work is happening as we speak.
They have achieved high-level consensus on the core mechanisms we just discussed, and they are preparing this foundational technology for an expected rollout in 2028.
Which is not that far away.
Not at all. This is the bedrock that billions of devices will rely on over the next decade.
It is a monumental undertaking, and it represents a massive shift in how we build our digital world. And I think this raises an important question, one that really gets to the heart of this societal shift.
Okay, what is that?
As Wi-Fi 8 transforms wireless communication from a best effort convenience into something as deeply mathematically dependable as a physical copper wire, what happens to our societal expectations of safety, productivity, and infrastructure?
That is a deep question.
We are talking about a rapidly approaching future where the vital physical operations of our society, drones delivering emergency medical supplies, heavy factory robots assembling machinery, even the continuous monitoring of our own vital signs, will rely entirely on an invisible tether of radio waves.
It requires a profound, almost unprecedented level of trust in the unseen technology around us.
It absolutely does, which leaves us with something quite provocative to consider.
I am listening.
If the engineering behind Wi-Fi 8 truly achieves this ultimate goal of wired-grade reliability, without the physical constraints of wires, well, the very concept of physical Ethernet ports, fiber optic drops in offices, and cumbersome cables eventually become historical artifacts.
Wow. Things we only see in museums to explain how we used to connect.
Exactly. And more importantly, as every single object around us becomes persistently, flawlessly, and invisibly connected, how will that fundamentally change our relationship with the physical world itself?
A fascinating question to ponder as we watch this invisible, incredibly complex infrastructure take shape in the air around us. And that brings us to the end of this chapter in the HFCL Time Machine. Until next time, stay connected to what's next.
You've been listening to HFCL Time Machine. For more conversations like this, find us on LinkedIn, Instagram, and YouTube.